Good day everyone, this is Third Engineer Alan A. Roberto. In today's video, I want to share an alternative way to interpolate fuel oil bunker levels using scientific calculator. If you're curious about the purpose of interpolation, please check out my previous video where I explained the manual method for interpolating fuel oil soundings. Today, we'll focus on the interpolation method using the statistic function of a scientific calculator. I want to note that while this method may be an alternative way, what is considered easy and efficient can be subjective. So without further ado, let's get started. So what do we have here? We have a sample sounding of 38 cm and a trim of -1.2, which indicates a forward trim. As we can see, there is no exact match in our sounding table for this value, so we cannot simply use our sounding table to find the equivalent volume for the sounding and trim. That's where interpolation comes in. In my previous video, I explained that using manual calculations requires a lengthy process. The first thing we want to do is to identify the floor and ceiling of our sounding and trim, and find their equivalent volumes in cubic meters. Here, our floor trim is -1.0. For clarity, we'll draw a table with column X for sounding and column Y for volume. We need to find the equivalent volume for our floor and ceiling soundings in the sounding table, which are 35 cm and 40 cm in column X, and write their corresponding volumes in column Y. Please note that every ship has its own sounding book, and the sounding book we are using here is specifically intended for this ship. For the floor sounding of 35 cm and the floor trim of -1.0, let's look at the table. For a good visualization, I will draw a rectangular box around the row for sounding 35 cm and the column for trim -1.0. Now, as you can see, it's at this intersection of the two boxes that we find the equivalent volume. This value is 2.7 cubic meter. Next, let's look at the ceiling sounding of 40 cm. I'll repeat the same process. Again, for a good visualization, I will draw a rectangular box around the row for sounding 40 cm while still keeping the trim at -1.0. Here, at this intersection, we find the equivalent volume of 3.5 cubic meter. Now, for the ceiling trim of -1.5, we will repeat the same process to find the equivalent volume for the sounding of 35 cm and 40 cm. Of course, this time, the rectangular box will be drawn around the column for trim -1.5. After finding the equivalent volumes for each floor and ceiling sounding at their corresponding trims, the next step is to find the equivalent volume for our actual sounding of 38 cm using the floor trim of -1.0 and the ceiling trim of -1.5. This is where interpolation comes in. We will be using the statistics function of a scientific calculator. To shift to statistic function, we'll press mode 3, then press 2 for the a plus bx function. This function is used to perform linear regression, allowing us to find the relationship between the input values, in this case the sounding, and the resulting output, the volumes. Now, we will plug in the values for x and y based on our trim of -1.0. Press AC to exit the data mode. Since we want to find the interpolated volume for our sounding of 38 cm, we'll input 38 into our calculator. Then press Shift 1 for stat, followed by 5 for regression. Since we want to find the value of y, which is the volume, we'll choose 5 for y hat. Finally, press equal to see the interpolated result, and we can write the value in column Y. Again, repeat the same process for sounding of 38 cm with a trim of negative 1.5 and write the result in column Y. With this data, we can use the same process in the calculator. Finally, we can key in the actual trim value of negative 1.2. Again, press Shift 1, then 5 for regression, followed by 5 again for Y hat, and press equals. This gives us the final result for the volume at a sounding of 38 cm and a trim of negative 1.2, which is 2.956 cubic meter. I hope you find this method as easy and efficient as I do. Now it's your turn. Can you find the volume when the sounding is 104 cm and the trim is negative 0.7? Let me know your answer in the comment section. Thanks for watching and see you on the next video.